Hi, my name is Anastasia.
My name is Jude.
And in the next some minutes, we are going to briefly introduce you to the concept of neural networks and its implementation in Python library Keras. How many of you have worked with machine learning? Maybe someone has worked with deep learning? So why are there two questions instead of one? Aren't machine learning and deep learning the same thing? For those who confuse these concepts, this diagram helps to position one concept compared to the other. Artificial intelligence is a large field of techniques and methods given to machines the ability to learn and solve problems like humans, or better than humans. Machine learning is only a subfield of AI, but a very large one that, as it's said by famous American pioneer in AI, Arthur Samuel, gives computers the ability to learn without being explicitly programmed.
So what is deep learning? Well, in terms of binary classification tasks, we can see deep learning as a set of deep neural networks which has the ability to transform the data from its initial space to another space where linear separation is possible. For those who work on deep learning, what are they doing? Well, everyone thinks differently. Maybe we think that we're working like some expert, for example, Randy Kang, the director of AI research in Facebook. But what we are actually doing is just importing some libraries such as Keras, because all the algorithms, all the structures are already implemented and are ready to use.
Well, even D claims that deep learning is easy, especially given the functionality of libraries like Keras. We shouldn't forget there is some math behind the simplicity of Keras functions. That explains the magic. So it's good to know it. We start with a discussion of the simplest type of neural network, the perceptron. That is also an elementary component of a deep neural network. We dispose the inputs x1, x2, x3, x4, each of them associated with a weight w. These weights are generated randomly at the beginning of learning, and then they are adjusted with a mechanism that D will explain later. After that, we calculate the sum of these inputs and their weights. Once sum is computed, it's passed through the activation function in order to be transformed into the final result.
Here is a concrete example. We have the real numbers, and each input number has associated weight. Then we do a weighted separation, and we get a result. Here, for example, it's 1.99. Then we choose a activation function. Here we use a sigmoid. And of course, it's possible to use other kind of functions as activation function. And from the sigmoid function, we can get a result, for example, 0.8. So this is the general idea of how a perceptron works. To get a model work, we need to train a model. Model training is done within two steps. The first step is forward propagation, which means that we get inputs in the input layer, and the model will calculate until the last layer, where we can get the predicted output, also called predicted labels. Then we have real labels. There's a function called loss function to calculate the difference between the predicted labels and the real labels. And the result of this calculation is called loss value. And here, we start the second stage, the backward propagation, which will pass the loss value to the first layer, to the input layer. And all the weights in the model will get adjusted according to this loss value. We repeat these two steps until the minimization of the difference between the predicted labels and the real labels. So this is the general idea of how to train a deep neural network models.
So here we have seen the simplest neural networks, but it seems not to be deep enough. Actually, the traditional neural networks have maximum 2 layers. Initially, because of lack of computational power, it was not possible to create deep neural networks. But with recent evolutions in GPU, we can now make the neural networks with more than 2 layers and even 100 layers. And this is what deep neural networks are. So every node of such a network is a perceptron, and multiple perceptrons form a layer. The layers are taken one after another, and the input of every subsequent layer is the output of a previous one. The nodes are interconnected, and the big learning happens the same way that Dick explained to you just now by multiple iterations of backward and forward propagation steps. So, if you want to implement neural networks yourself, there are tons of frameworks from low-level libraries to high-level ones. It depends only on your needs, whether it's a research project or a basic quick implementation. So our choice for this project is the Keras library, and let's see how it works on a practical problem.
Given the input x, we need to label it 1 or 0. In machine learning, it's called prediction. So because we have to classify our instances into one of these two sets, this type of classification is called binary classification. If we visualize our data with this graph, where the blue triangles represent the label 0 and the red circles represent the label 1, we can easily observe that the data is not linearly separable. That means we should look for an algorithm that can transform the data into a state where linear separation could be possible. Here is a visualization of how a deep neural network model can transfer data from one space to another space so that the data can be linearly separated. Here, in the left plan, the training is already finished. Then we can say that the plan is divided into two parts with different colors, which means this model can already predict new data. And in the right plan, here each button represents a layer in the model, and each layer can perform a transformation. For example, this is the first layer, which can transfer the initial data space to this form. Now here, this is the second transformation. This is the third one. Now we can continue this until the last layer. We'll get a data space of almost 1D dimension. And from this data space, linear separation is quite possible. So this is the general idea of how the transformation is performed by the models. But how could we do this with Keras in Python? First thing, we import the libraries, and then we prepare data. For example, we need to generate data and then label them and divide them into training dataset and test dataset. And then we begin create a model. We start with a class called sequential in Keras. And then we can add layers like this, just point and then add. For example, first layer, we can use a dense layer, where we need to define number of nodes, the name of activation function. And here, because this is the first layer, we will also give the parameter called the input shape. Here we use 10 because our data has 10 dimensions. We can continue to add some other layers. For example, we add another dense layers with number of nodes and other parameters. At the end of the model, we need to define output layer, where we could use a layer called dense layer with only one node, and the activation function should be sigmoid.
Once you are done with the construction of the model, you can configure its learning process, the compile method, specifying the parameters like the name of loss function and optimizer. By the way, you can even further configure your optimizer, specifying its hyperparameters, like learning rate, decay of learning rate, the momentum updates, and so on. With the fit function, we start the training process on our training set. Iterating on the epochs, the number of which is passed as attribute to the fit function. along with the number of samples per each gradient update and Boolean parameter to shuffle the data before each epoch. Here we go. We see clearly the evolution of the model during the learning. With each iteration, the value of the loss function is decreasing, while the value of the accuracy is increasing. The built-in function evaluate, we can in one line assess the performance of the final model which passed through all the iterations. So here we see that the results are very satisfying, high accuracy and low error.
Finally, we'll talk about the advantages and disadvantages about deep neural networks. For its advantages, firstly, there's no need for feature engineering, and in the domain of machine learning, feature engineering can be very time-consuming. Next one is that there's no limit for the number of data that you can use during the training. Third advantage is that it's sustainability, which means that we can use the model always, and we can easily implement some training strategies such as online learning, which can be very important in the production environment.
But there are also some drawbacks and inconveniences of using deep learning. There are a lot of hyperparameters to configure in your network, and there is no rule of thumb how to do it. You have to experiment in order to find the set of hyperparameters that performs well on your data. Recently, the creator of Keras, François Chollet, published an article on the limitations of deep learning. In this article, he explains that despite the fact that the range of applications of deep learning is wide, nevertheless it's limited. So for some problems, neural networks will give good results, but for others, they will suck. And finally, while neural networks can approximate almost any function, they can't tell us about what this function is. So we will never have a statistical explanation of its wonderful performance.
Thanks for your watching. Please share and comment or ask us questions. We'd like to discuss with you further.
Thank you.
Thank you.